Hello, Harry. Good afternoon. Today, Harry and I are going to talk about a project started about 10 years ago, involving a rare incunabulum, a kind of side project to work on whenever possible, and has proven an invaluable tool for learning over the years. It shows the reality of working on a project within other duties of a large collection, and also how our understanding of materials has developed over the years. Articella is a collection of medical works used as a textbook by university students, being an essential tool for medical teaching until the 16th century. This first edition, printed in 1476, is the only copy held in Britain, with only 9 copies held elsewhere. It is a folio-sized volume with a large and thick text block made up of 29 sections of 4 by folio each, Venetian thick paper, printed in black ink and rubricated in vermilion and azurite. Presumably, it was resewn and rebacked in the early 1980s. The late book conservator, Mr. Clarkson, and I collaborated to the disbinding stage of this volume, and we presume that back in the 80s, during a similar stage, the spine lining might have been soaked with liquid paste or similar material, used as poultice for lining removal, causing the animal glue of the original spine linings to penetrate through the spine folds of the sections, resulting in severe and wide staining. The sections were resewn, the spine covered with a thick layer of PVA applied directly onto the spine, followed by a leather lining also applied with PVA, rebacked, wooden boards replaced, the original leather partially reused. The dark staining, in some cases oily looking, that affected each spine fold of this volume was on average 50 millimeters wide, often reaching the printed and rubricated areas. The sewing structures had started to fail because the spine folds had become brittle and stiff and needed to be softened before resewing. I started testing and trialing stain removal treatment, finding the right solvents, working locally in fume hood, brushing it on a suction table. It was necessary to treat both sides of the folios until the stains would be gone. The trials confirmed that the original paper in treated areas had lost its rigidity, becoming flexible again. Within a year or 2, I could have completed the treatment, but I wouldn't have learned very much from this experience. So I started to widen my treatment options. In 2012, I sought the expertise of Victoria and Albert Museum scientists who carried out the analysis of the stained paper and of the PVA. In the meantime, conservators were increasingly working with gels, and I attended courses with Richard Wolbers, where I had the opportunity to discuss the Articella with him too. In 2013, Melissa Lewis, UK-based paper conservator, and I carried out some tests together, also making the most of the controlled treatments offered by gels, allowing us to work safely on several folios simultaneously. I felt that this project was an opportunity for more research and try new, safe, but speedier techniques. In 2015, I presented my problem to Harry Singh. He was developing an ultrasonic cleaner for organic materials or museum objects, and it was immediately clear that his system had great potential in conservation. We were able to do trials on those stains even without getting the object out of the store, by using the blotters that were carrying the stained material shifted from the folios during treatment previously done on the suction table. As generous as it sounds, Mr. Alan Profit from Rainbow Electronics, following Harry's and my directions, designed and provided Wellcome Collection with this bespoke ultrasonic system, made with the intent to work on large areas at once. Meanwhile, Harry and I continued experimenting with his HDS equipment and fine-tuning it specifically for the Articella, involving also the use of different sized and shaped probes. Harry also built an automated hand-free setup with a custom-made bridge for a suction table, which he will be talking about. So how does it work in practice? On a suction table, positioning each folio on blotters, leaving a gap in the middle so that as the stained area is sitting on layers of replaceable blotters to reduce waste, the solvent is applied on stains, prop onto all, as mostly worked best in my case, with a liquid dropper bottle instead of a brush for more continuous and controlled applications of the solvent. Then a layer of Evalon is placed on it and wetted with the same solvent. The probe is then positioned on these wetted layers and moved and held gently over them. The ultrasonic helps to shift evenly and efficiently the stains into the blotters below, reducing the treatment time considerably with no need to work on both sides of the folios. Regarding the science of it, I will hand over to Harry, who will talk about it in more details.
Good afternoon. My name is Harry Singh, and I am the founder and director of HDS Ultrasonics Limited. For over 30 years, HDS has developed and supplied specialized ultrasonic equipment specifically designed for paper conservation, collaborating closely with the conservation community to provide tailored solutions, particularly in the custom encapsulation of documents using polyester film. This method of research and development was used to refine the HDS Keeper range of document encapsulators and the HDS ultrasonic spot welders. It is both a pleasure and a privilege to have this opportunity to share with you some insights drawn from the research and development work that Stefania and I have been conducting over the last 10 years or so. To begin with, I would like to explain a few of the basic principles relating to how the ultrasonics work during the ultrasonic cleaning process. The term ultrasonics refers to the study and application of sound waves with frequencies that are above the range of human hearing. While the human ear can typically perceive sounds between 20 and 20,000 Hz, ultrasonic waves have frequencies higher than 20,000 Hz. We have developed an ultrasonic generator that creates a 40 kHz electrical signal, which is transmitted to the handheld transducer and probe assembly. This assembly converts the electrical signal into mechanical movement, much like a loudspeaker. This causes the tip of the probe to vibrate microscopically at a rate of 40,000 times per second. When the tip of the probe is placed over a stain, pre-treated with a cleaning agent, microscopic vibrations pass through the cleaning agent, resulting in a micro-agitation effect that enhances the removal of the stain. I began my research around 2014 when I approached Martin Jones at the British Library, where experiments were conducted on tape stains with the assistance of Kim Mulder. I also approached Joanne Hackett at the Victoria and Albert Museum, where the ultrasonic cleaning proved to be very effective on fabrics and textiles. I was approached by Stefania at the Wellcome Collections in 2015, who agreed to conduct some scientific trials and testing of the ultrasonic cleaning of stains. It was coincidental that at the time that I was approached by Stefania, she was working on a rare Incunabulum. We realized that if this new technique was to prove to be successful, it would be an asset for this project as well as many other stain removal projects. We also realized that it was a large project which would take a long time to complete. Our initial trials were done using a 60 kHz unit, which worked well on smaller areas, but we needed a unit that was able to cope with the larger areas of stains. So we then continued our trials using the 40 kHz unit, which has a physically larger transducer and probe assembly. Because of the sheer size of the working area, we also conducted experiments with a couple of bridge assemblies that were designed to sit across the suction table. One could be moved by hand, and the other was moved by a programmable speed and direction motor. This was done to provide a precise and stable mounting of the transducer and probe assembly, and allowed for a hands-free style of operation. It has been a huge pleasure to work with Stefania on this project, as well as having the opportunity to share our findings with you today. I think that we have both learned much over the last 10 years, but are probably only seeing the tip of the iceberg with regards to the potential of ultrasonic stain removal.